So we'll be studying about Model 4, Data and Analytics for IoT. So these are topics that we'll be discussing. First is Introduction to Data Analytics for IoT. So in this model, we'll try to understand what is data and analytics for IoT there. In general, we'll try to understand in brief introduction about data analytics for the IoT and what is the difference between structured and unstructured and how analytics is related to IoT data. First, we'll try to understand how data analytics can be analyzed with respect to machine learning. So first we'll try to know what is machine learning, what is the types of machine learning, for what purpose machine learning is used with respect to the IoT. And next we'll try to understand about what is big data analytics tool and what is technology and what is edge streaming analytics and network analytics. These are some of the topics that the model 2 will be covering. So first we'll try to see what is the data analytics. So basically in the word of IoT, so IoT means what? It's a massive amount of data which are obtained from sensors, and one of the important challenges is how to transport this data, how to manage this data. For example, if you are going to consider here we'll try to discuss about one example, that is a commercial aviation industry in which the sensors are deployed through the aircraft. So in this, that is in aviation means obviously it is nothing but what? It is about modern jet engines. So where modern jet engines are fitted with thousands of sensors, they generate a whopping 10 GB of data per second. So modern jet engines basically are equipped with how much sensor? 5000 sensors here. And this 5000 sensors which are present, which are used with respect to modern jet engines, it is going to generate nearly about 500 terabytes of data daily. That means what kind of data? Obviously we know that when aviation means it will be in the air, so it needs to collect various data. What is the atmosphere, what is the latitude, what is the latitude, longitude at which the plane or jet is moving there, and various other data will be collected there. So in data analytics, we are trying to analyze the data collected. So the thing is, with the help of IoT, that is the sensors, we can collect 500 terabytes of data daily. Similarly, in today's life, aircraft has thousands of other sensors which are connected and which can generate still more terabytes of what? Data here. That means it's the beauty of the Internet of Things, which is helpful for us to connect the data in the air also by installing the sensors in the plane, in jet engines, aircraft. And there are two ways of collecting the data. One is structured data, other one is unstructured data. So here both structured and unstructured are different tool set for data analytics perspective here. So we can see from the figure itself, in a structured data is nothing but it's an organized formatting. It can be used for spreadsheet databases. Unstructured data, it doesn't confine to any one particular model. It can be used with respect to text, images, video and speeches also. The same definition here. So structured data means the data follows a model or a schema here that defines how the data is represented or organized, meaning it fits well with the traditional relational database. And the example for this structured where what the values which are collected here for structured is temperature, pressure, humidity. And structured data is easily formatted, stored, queried and processed. And example for this is Microsoft Excel and Tabula. And people are more familiar and comfortable with working with structured data when compared to unstructured data. Whereas in unstructured data lacks a logical schema here for understanding and decoding the data here. And examples of different type is text, speech, image, videos, and it contains 80% of business data here. So when you go with respect to what the structured and unstructured, here with the machine learning applications such as natural language processing, we can decode the speech. With image facial recognition application, we can extract critical information from videos and images and videos. So these are nothing but the application with respect to what unstructured data, where we are going to decode the speech by using NLP, and we are going to use image or facial recognition application where we can extract the critical information. Next type is data in motion versus data in rest. The name only tells here, as in most network, data in IoT is either transmitted, this data in motion, or held or stored in the data at rest. Example of data in motion includes client and server exchanges such as browsing, file transfer, or email. Data saved in hard drive or storage area or USB drive is referred as data at the rest. Data in motion means it is in active state. Data in rest means it is in the passive state. These are nothing but about the different what we call it as types of what data: structured, unstructured, data in motion, and data